Welcome back to Geometry Chapter 12, Section 2, Part 1 in this book. We're talking about surface area of prisms and cylinders, and I think it's going to be too much for one video because it took me the whole board to do prisms. So I think cylinders is really going to be for the second part, for the math part of it. Alright, so what is a prism? A prism is a polyhedron, a solid shape that has two parallel faces, which are called bases, and they're connected with lateral side faces. So this is a prism, and I know you think of a prism just as the triangle one that you use to split the light and make the rainbow. But really, this is a prism too, because it's got two congruent parallel faces, and then it's got other faces that connect them. Okay, so that is actually a prism. So is this. So it's got two congruent faces that are connected with lateral faces. And you know, I am not getting, even though I have product placement, I'm not, just full disclosure here, I'm not getting any money from Crunch and Munch. But I'm being distracted by Crunch and Munch because I want to eat this now. Alright, so that is also a prism. This would be a prism also if it was solid. It would have its two congruent parallel faces connected with lateral sides. Okay, let's see what else we got. This would also be a prism. These are the two congruent faces. These are the lateral sides. So I have a whole stack of them. I've got this one and this one and this one. All of these would be considered prisms, okay? The other thing we're going to talk about is the cylinder. With the cylinder, the bases are circles and the lateral side is a rectangle. Once again, no money from Quaker Oats with my product placement. But even though I'm a math influencer. So this one, the bases are circles. See, it's a circle on that end and a circle on this end. And if you imagine, if I cut this open, I still have oatmeal in here so I can't. If I cut this open and spread it out, this piece, if I cut it down the side and then spread it out, would be a rectangle. Or it'd be a rectangle. Okay, so can you imagine that? Now do you want some Quaker Oats? I'd rather have the Crunch and Munch this afternoon. I'm ready for a sweet snack. Alright, so the height is the distance between the two bases, and so that would be the height of this one. This one, if it's oriented this way, this is the height, but you know, these could be the bases because they're identical, or these could be the bases because they're the identical. If these are our bases, this is the height. If this is our bases, that's the height. If these are our bases, that's the height. Alright, so if it is a right prism, and these are, then this is a right angle. But could you imagine if this was like the Leaning Tower of Pisa and it was squished over, where the bottom was flat and the top is flat this way, but it leans over. There's a picture of it in your book. Look on page 728 and you can see it. If it's not a right prism, if it's pushed over like this, the height is from the ground to the top, not the slant height. So this would be, imagine this is a cliff. And if you rappelled off of it and went down, that's the height. If you hiked up the side of it, that's the slant height. I went rappelling in college once, and it was just like this. We jumped off the cliff and we were going down, and I thought it was going to be like a Mellow Yellow commercial where I'd jump and go whee and, you know, slide down. But the rope was heavier than me. And that had something to do with ratios or whatever. And so I would have to just shove myself down the rope. And it wasn't as fun as I thought it was going to be. I went off something that was equal to an 11-story cliff. So I've been in downtown Atlanta when I went to Georgia State. And looking at those 11-story buildings, I count them and go, I jumped off something that tall. And it was a lot scary. It's a lot scarier looking at a building than the cliff. The cliff just seemed like, yeah, woo, I'm having fun. All right, so here our height is if you went down by a rope. Rappelling. Okay, the surface area is the area of all the sides added up. So I would get the area of each one of these and add it up, whether it's a right prism or not, or whether it's a cylinder. You just get the area of each side and add them all up. And the SAT, the ACT, and the college entrance exams like these multi-part problems. The lateral area is just the area of the sides, the lateral ones. Okay? The surface area of a right prism has a special formula. The surface area is 2 times the area of the base plus the perimeter times the area of the height. And if you think about it, you can kind of see it better with the oatmeal. If I'm getting the lateral area of the lateral sides, imagine that I cut this open and it then folds out to be a flat piece of paper. Well, the area of a piece of paper or any rectangle is length times width. So if I had the perimeter, that's the same thing as the length. And the width is the same thing as the height of this rectangle. So that's why it's the perimeter times the height. And same thing here. Perimeter is like the length, if you unfolded this thing, times its height, which we're going to talk about up here. Okay, so and then 2 times the base is 2 times the area of the bases, not just you have to get the area of each one. Usually by length times width, unless it's a cylinder, it'll be pi r squared. Okay, what is a net? Not what you catch a fish in or where is pantyhose or whatever. A net in geometry is if you take one of these shapes, imagine it's cardboard and unfold it. You know, if you ever worked at a pizza restaurant, the boxes don't come folded up. You have to fold it. Well, when they're all flat like that, in geometry, that's called a net. Same thing with this. This box was printed on a flat piece of cardboard and cut out and then folded into this box. When it was all flat like that, it's the net. You can see pictures of it in your book on the top of page 729. This is where I drew the cube. See, here are the 4 sides and there's the top and the bottom. Here's my oatmeal. There's the sides, there's the top and bottom. Those are nets. Now here's a typical problem. What is the surface area of my Crunch and Munch box? It's 3 inches on this side, 5 inches on that side, and 8 inches on this side. I know I drew it ugly, but they have it looking better in the book if you want to see it. All right, so to get this surface area, I can add up each one. So I have 2 sides that are 3 by 5, which would be this bottom side and the top side. I have 2 of them that are 3 by 5. So that's length times width times 2, and that's 30. Then I've got 2 that are 3 by 8s. They're these end pieces. I have 2 of those. So I multiply 3 times 8 times 2, and I get 48. And then I have 2 of the big side pieces, which would be the back of the box back here and the front of the box up here, if you can imagine that. And so those are 5 by 8, so 2 times 5 times 8 is 80. Add them all together, the area is 158. This is probably the easiest way for me to do it. I make sure I have each one, I check it off, I add them up, I know it's right. I don't take shortcuts. Okay, here's another one. They want the surface area of this. It's right, so I can do the formula. And so the bases are 10 times 5. Okay, which is 50. And the perimeter is 10 plus 5 plus 10 plus 5, which is 30. So now I can put it in the formula. 2 times 50 plus 6 times 30, because 6 is the height, and I get 280 inches. Also, we can do it with this. Imagine it's solid. Here's our triangle. It is a right triangle, and we want to find the surface area of this right shape. Your book uses that weird formula, 4 times the square root of 3 thing. I did it with trig. Honestly, that's how I would do it. So here's my way. I have 3 sides that are square, and they are 5 by 7, so they're 35. And then I've got 2 of these triangles on the end. I know that because it's regular, they told me, that these 3 angles are 60, because 60, 120, 180, the 3 angles of a triangle. If I cut it in half to make it my right triangle, then my theta, instead of being 60, is just 30. And my height is the adjacent of that theta. So, caught another horse. The cosine of 30 is the height, my x, over the hypotenuse 7. Y is x all alone. It's being divided by 7. I multiply both sides by 7. So 7 cosine 30 is the height. It's 6.06. And now I have two triangles like this. And this is what one of those is. Area equals 1/2 base times height. 1/2 7 times 6.06, which is 21. Now I have 3 of the sides at 35 plus 2 of the triangles at 21. Add them up, and the answer is 147.43. That is the logical way to me to do it without having to remember special formulas. All right, come back and we're going to come for part 2. This is part 1. Come back for part 2, and we'll talk more about cylinders. Math is great.